3. A simple random sample of size n is drawn with x bar being 18.5, n being 34, and s being 4.9. We want to determine the margin of error for a 95% confidence interval. So for that margin of error, the calculation for that is going to be t sub alpha divided by 2 times the sample standard deviation divided by the square root of the sample size. So in this case, this will be t sub 0. We want 95% confidence interval, so alpha is 5%, which means alpha divided by 2 is 0.025, so 2.5%, times sample standard deviation of 4.9 divided by square root of 34. Or again, we could use the template that I have on here, this time without data, to give the sample size of 34, the point estimate of 18.5, sample standard deviation of 4.9, and confidence level of 0.95. That gives us the t-value of 2.03, standard error of 0.8403, which you could see is what happens if we did 4.9 divided by the square root of 34. We get the exact value, which is good. Anywho, it gives us the margin of error right here of about 1.7097. So margin of error of 1.7097. And we want the 95% confidence interval around our population mean mu. So it's x bar plus or minus that margin of error. So 18.5 plus and minus 1.7097. But you might have also noticed it's inside of my table in here as well. So lower bound will be 16.7903 and upper bound of 20.2097. So the lower bound of that was going to be lower bound was going to be 16.7903, while the upper bound was going to be 20.2097. So the 95% confidence interval, 95% confidence interval is 16.7903, less than our mean mu, which is less than 20.2097.